What has happened?
I really don't know. The thing just ended and they told me someone has started another meeting in the same account. What happened?
I've made you a host to answer again.
Okay. I don't know what happened really.
I've also seen something of that nature and then I wondered. Arthur is there, make him co-host.
Okay.
I'm sorry for the inconvenience. I don't know what happened. Chalisa, can you hear me?
Yes, I can hear. I'm not seeing the activity also. And I think the students had already started getting the numbers, the answers. They should.
Maybe they should raise up their hands to tell us what they have gotten.
Okay.
Are you seeing any hand raised on this part, eh?
No, not yet. Let me wait and see. I can see some answers in
the chat. Eh?
There is some. This one is called Daphne Clever. I think she should unmute and say something. I've seen her listing numbers up here.
Okay, Daphne, unmute yourself. Daphne, are you there?
Yes, teacher.
Yes, the question, thanks for the contribution. Eh? The question was saying, use the number line below and write down the inequalities represented in each case. So you have to use inequality symbols, not to listing those numbers. But numbers, they are all in that domain. They are there from negative up to 6. But this arrow shows that the numbers, there are so many, they are endless. That's the meaning of that arrow. So I wanted you to use the inequality symbols. Inequality symbols, straight that one. Do you have any other contribution? Thanks for the contribution.
There is another answer in the chat here. Benjamin is telling us some answer here. Let him unmute and mention it. Benjamin,
unmute yourself.
X is greater or less than or greater or equal to -2.
Yes, thanks very much, Benjamin. Thanks very much, Benjamin. Yes, this bold circle, it means that this negative is also what? It's negative 2 is also included. So it means when you're writing, we say that it is X. You can use any other unknown. You can use Y, you can use any other unknown. So you can say that X is greater than. Who's that one? Mute yourself.
Let me maybe unmute everyone, then you unmute yourself. Okay, Teacher, I think we can proceed.
Greater than or equal to? Greater than or equal to -2. Thanks very much, Benjamin. Thanks very much for that. Yes, let us continue. Another one, we have this one. We have this part B. Want to use inequality symbols to represent this. How to use inequality symbols to represent that. I'm giving you 50 seconds. Complete that. This part B. Write this part B. You can write it in the chat, or you can just unmute yourself and tell us the answer. You can just raise up your hand and we pick, then tell us the answer for part what? For part B. You can also type in the chat. There's someone who has done it. Part B. Elsa, do you have anything in the chat? Yes, are you there?
Oh, sorry, I unmuted my. Oh, I'm seeing Heaven in the chat. She has the answer even when she has written it in words. I wanted her to unmute, then she explains what she has written here in the chat.
Okay, Heaven, unmute yourself.
Yeah, she should be delaying. She has written
Yes.
-2 greater or equal to 5. Greater or equal to 5. I don't know whether she could.
I'm around.
Okay. Yes. Thanks for the trial.
Heaven. Then we have Kigund is putting up the hand.
Yes. Kigund, tell us the answer. Benjamin, tell us the answer. Unmute yourself.
Oh.
Benjamin, are you there?
Benjamin must have dropped. I can see another person in the chat. Actually, we have Mchanguzi is saying -2 is less than 5.
Okay.
Then Chigund has come back and is saying -2 is less or equal to. Oh, this one has said, has written something very close to the answer. This should be the answer. And it's saying, maybe you write it on that board there, write in some open space. I read it for you. It's saying -2. Are you writing it?
Yeah, I'm writing it. -2.
Yes, -2
yes.
is less or equal to x.
Is less or equal to x. Yes.
Less than 5.
Less than 5. I think this one has gotten the answer correctly. A -2 are less than or equal to x, less than or equal to 5. This bold one is meaning that -2 is what is included. Then this open circle is showing that this 5 is not included. That's why he or she used the less than without or equal But for this one, for the first one, use the negative 2 greater or less than or equal to x. That is good. That's good. Means members we are attentive. Let us continue. Then we have this one. Number 2, write the following using inequality signs. That is part A, x is greater than or equal to negative 5. Greater than or equal to negative 5. I think you can just write it somewhere. And just write it somewhere. X is greater than, if you have a book, just write it in the book. X is greater than or equal to negative 5. Then another one is x is greater than, k is greater than or equal to negative 6 and less than or equal to 14. So using inequality symbols, write that. Write that in your books.
You can see Benjamin is already having an answer here.
Yes.
And he's telling us that x is greater or equal to negative 5. I think that is correct. Let's wait for others to bring and keep the answers coming into the chat such that we read them out and we proceed.
That's very good, Benjamin. For the, that's very good. I'm liking the contribution. You're just so active. That's good. I think teacher Lisa, you can go with continue with the lesson. This one's I think
Daphne has also the right answer here.
Okay.
Daphne Clever is also correct. I think we can proceed. Let the answers keep coming as we proceed with the lesson.
Okay. So in today's lesson, we are going to talk about solving inequalities. Solving how do we solve these inequalities? That's what we are going to look at today. Solving inequalities. And we are going to talk about linear inequalities in one unknown solution. So when someone talks about linear inequalities, what comes to your mind? Linear inequalities. Linear inequalities. When someone talks about linear inequalities, what comes to your mind? I'm saying that a linear inequality, that one where I have the unknown in that inequality, its power is 1. When the power to that unknown in the inequality is what? Is 1. We have inequalities whose powers they are in 2. Someone can write an inequality of this nature of x squared minus x minus 6 is greater than 0. This one. So when someone writes this, this is not a linear inequality because this power is in what? Raised to 2. So it is not a linear inequality. But linear inequalities I can talk about when you can give an example of this x minus 2 are greater than 6. So the highest power here is what? Is 1. So that's what we call a linear inequality in one unknown. So that's what we are going to look at. That's what we are going to look at today. So you're saying that who can read for us this? Hope you can see the screen. Eh?
Yeah, I can see people are putting up the hand. Maybe you give them chance.
Yes, pick one.
Raula.
A linear inequality is an inequality for which the highest power of the variables is 1.
Yes, that's very good. Eh? A linear inequality is an inequality for which the highest power of the variable is a 1. Eh? As I've explained, that you have inequalities whose highest power is greater than 1. Those inequalities, the quadratic inequalities, like that one I've given you, where I have x squared minus x minus 6 greater than 0, that's not a linear inequality. But when we talk about a linear inequality, that inequality for which the highest power of the variable is 1. People should mute themselves.
Let's proceed.
Okay. So when we are solving these linear inequalities, we follow some rules. So some rules must be put. Who's that one? So when we are solving,
some people here. Let's unmute. Let's mute ourselves.
When we are solving these inequalities, follow certain rules. Like some people at home, some families, they follow some rules. Some people say no eating food beyond 7, no eating supper beyond 7 p.m. Some people they have their rules they follow. So even here in mathematics, in inequalities, when you are solving these inequalities, we have some rules we follow. We have to put into consideration before solving any inequality. So we have the addition principle. So we have the addition principle. It is a step. It's a step we follow. And it is saying that adding a constant on both sides of the inequality symbol leaves the order of the inequality unchanged. That is the step we follow with addition. It is saying that when you add a constant is any number, can say any number, can say 2, 1, even other constants which don't have any variable. Okay, when the variable is raised to power 0, so that's a constant. So when you add a constant on both sides of the inequality symbol, it leaves the order of the inequality unchanged. For example, when I have an inequality like this, plus 6, and say less than or equal to 2x minus 2. This principle says that when you add a constant, so you can pick any constant. When you add any constant this side, I can pick any constant. Which constant should I pick? Yes.
Is it possible to add that constant using a different color?
Okay.
Try.
Let me use a different color. When I add a constant this side, I can use 4. Also this side, I put 4. So this one, I leaves the inequality unchanged. So there is no, the inequality hasn't changed by adding these constants. Because when this 4, it is a positive this side. When it crosses the inequality sign, it comes this side, it's going to become what? It's going to become negative. It's going to become negative. So at the end, we shall get the inequality remaining the way it is. For example, when you try to remove this 4 is going to cross. It's going to cross the inequality sign this side. Since it is positive, it's going to become what? It's going to become negative. So it is 2x minus 2 plus 4. This 4 here. Then I subtract this what? This 4. So at the end of these 4s, they are going to cancel, and you get the initial inequality. So that's what we are meaning. That also, if I have another inequality, I can give another example. If I have x greater than y. This is an inequality. If I add a constant here, for example, 1, I'm going to get x plus 1 greater than y plus 1. If I add, doesn't matter which constant you are adding on both sides. So it doesn't matter. So this one, for example, if I add a constant, if I add that constant, if I add this constant here, so it doesn't change the inequality. It means if this one crosses the inequality sign, because that side is going to get a negative sign, of which these ones, they are going to cancel, and the end, it remains with x greater than what? Greater than y. So that is the addition principle. The addition principle tries to highlight that when you add a constant on both sides of the inequality symbol, it leaves the order of the inequality unchanged. So that is the addition principle. That is the addition principle. And you have an example here saying that solve 3x. Solve 3x minus 1 less than or equal to 2x minus 3. So when you talk about solving, you solve up to when you get that variable. Which range does that variable fall? So after I have to graph, have to tell us the range where that variable falls. So we need to solve this example. So this is the question. It is 3x plus 1 less than or equal to 2x minus 3. So what are we going to do? We are going to...
Arthur?
Yes?
I don't know whether that is a plus. Because the question has a minus.
This is not. Okay.
That's it. What of the solution?
Let us try to solve it here. It is 3x, 3x minus 1 less than or equal to 2x minus 3. So that is our question. We need to solve it. So what we are going to do, we are going to remove, we are going to collect like terms. We are going to collect like terms. This constant, the -1, is going to cross this inequality sign. It goes on right-hand side. Also, this +2 is going to cross this inequality sign. It comes on the left-hand side. But I'm going to work on one by one. I'm going to start with the constants. I'm going to start with the constants. So I'm going to remove this -1 from the left. Then it goes to what? The right, where I have this -3. That's where I'm collecting the terms from. So I'm going to say -3x minus 1. So remember this -1, this one is a negative. This side is for this one. So it is -1. As it crosses the inequality sign, it changes the sign. The inequality symbol, it changes the sign. If it is negative, it becomes what? It becomes positive. So what I'm going to do, I'm going to add a 1 here. This is the constant I'm adding. So I'm adding a 1 there. So you maintain the inequality symbol is less than or equal. Then 2x minus 3, and then plus what? Plus 1. So when you look at the second step and the first step, you notice that I've just added a constant. I've added a constant, and this is the constant I've added on both sides. This is the constant I've added on both sides. I've added the +1 on the left and the +1 on the right, but doesn't change anything. Doesn't change anything. So it means that this -1 plus 1, it is a 0. When you get -1 plus 1, you are going to get what? We are going to get a 0. So we are going to remain with 3x. 3x on the left. Remember this one, -1 plus 1 is what? It is a 0. So less than or equal to 2x. So I want someone to tell me the answer of this one. This one. A -3.
It's negative.
Negative.
It's -2. That's very good. Yeah, it is
Yes.
-2. It's -2. So I'm going to write a -2. So that's the third step. So what I need to do is to collect the what? The like terms. Again, we are seeing 3x on the left, then 2x on what? On the right. So they need to come together. They need to come together. So I'm going to remove this -2. This 2x is going to cross the inequality symbol. It comes on the left. Remember, it is positive. It is positive. So it's going to become what? It's going to become negative when it crosses the inequality symbol. So you are going to get 3x minus, remember it was positive, it has a positive sign here. So when it crosses the inequality symbol, it's going to get that negative sign. So it is negative, it is 3x minus 2x less than or equal. So what is remaining this side? Remember this one has crossed the inequality what? Inequality sign. So this side you are remaining with the negative 2. You're remaining with negative 2. And this one has already crossed the what? The inequality sign. So when you get 3x minus 2x, what do we get? Someone to unmute him, say for himself.
It's
X.
X.
It is X.
It is x. We don't say one x here. We just know that that one is there. Just say x.
Yes.
So it is x less than negative 2. So here, this is the solution. But then we are saying that you graph after. You tell us that range. If they tell you to graph, then you graph. If they tell you that you graph this inequality you've gotten here, we are saying that x is less than or equal to negative 2. So we draw a number line. We draw a number line here. So this is 0. Don't forget to put the arrows. When there are no arrows, means that your number line is wrong. So you need to put on these arrows to show us that these numbers, they are endless. There are so many. When you go in the negative direction, when you go in what? In a positive direction. So this is negative 1, and this is negative 2. This is negative 3, and this is negative 4, and so on. So on. I'm going to put some few digits here on the positive side. This is 1, and this is 2, and then 3, and then 4. So according to the solution we've gotten, we are saying that x is less than negative 2. Which numbers are less than negative 2?
Negative 3.
Of negative, now there are those numbers less than negative 3, less than or equal to negative. So they are in the negative direction. But remember, the inequality is saying x is less than or equal. It means this negative 2 is also what? It's also included. So use a bold circle, not an open what? An open circle. So you draw in your arrow starting from negative 2 and that direction. So that is the addition. That is the addition principle, saying that when you add the constant on both sides of the inequality symbol, it leaves the order of the inequality unchanged. If that order unchanged, as you've seen here, I've added +1. I've added 1 this side, even this side, I've added 1. But the inequality remains what? It remains unchanged. It has no effect. That constant has no effect on the inequality. For members, that is clear.
Yes, teacher.
Okay, let us continue. Let me rub off the chalkboard. So let us continue. This first step has had an error, but that is the solution. That is the solution, which is x less than negative 2. So we also have the subtraction principle. That's another step we follow. And this one, the subtraction, I say that the subtraction of a constant from both sides of the inequality symbol leaves the order of the inequality unchanged, as in the addition principle, as we've seen, and the order of the inequality remains unchanged. Means unchanged when you subtract a constant on both sides. The problem comes when you just subtract on one side. When you just subtract on one side, then it changes the inequality changes. For example, when I say x less than y, then I subtract a constant this side, I say x minus 1 less than y. So this is a different inequality. This is a different inequality compared to what? Compared to the first one. But if I subtract these constants on both sides, on both sides of the inequality symbol, there is no problem. The inequality means what? It means unchanged. Yeah. Hope that is clear. Let me continue. So this is an example on the subtraction principle. The subtraction of a constant from both sides of the inequality symbol, it leaves the order of the inequality unchanged. Gives the order of the inequality unchanged. So that is the question. The question is saying solve the inequality, that is 3x plus 1 less than or equal to 4x minus 5. So we are trying to solve this one. So as we've done in the last example, we need to collect what? We need to collect like terms. So we have to take this one. Remember, this one is on the negative on the left-hand side. So we need to collect. We need to take this this positive one, where I have the negative 5. So we are going to put it there. Remember, it is positive. So it means we are going to. It's going to change the sign from positive what? From positive to negative. So you are going to say it is 3x plus 1. We are going to subtract. Remember, it is changing the what? It is changing the sign. It is crossing the inequality symbol, which is less than or equal. So it is less than or equal to 4x minus 5. So I've told you when you subtract on one side, make sure also subtract on what? On the other side. You have to subtract the constant from both sides of the what? Of the inequality symbol. Not on one side. So when you subtract on one side, the inequality changes. So you have to subtract on what? On both sides of the inequality. So if I say minus 1 here, it means I have to also subtract minus 1 on the right-hand side. So if I have 1 plus 1, they are going to do what? They're going to cancel.
Participants.
They're going to cancel. I remain with 3x. This side I'm going to remain with 3x. Less than or equal and 4x. 4x. Who can tell me the answer of this? Negative 5 minus 1. What do we get?
Negative 6.
You get negative 6. Don't tell me negative 4. Negative 4 is wrong. Some people have that tendency of bracketing. You are given negative 5 minus 1. So what you do, you bracket it. You bracket this. You get negative 5 minus 1, you get 4. This one is wrong. This one is wrong. Don't bracket. This negative is for what? It is for 5. So it is negative 5 minus what? Minus 1. So you get negative 5 minus 1, you get negative 6. Get negative 6. So that is done. That is done. So what next? We need to correct like terms for this unknown. How 3x and 4x. So this 4x is going to cross the inequality side, the inequality symbol. Remember, it is initially positive. So it is going to be a 3x. If it is positive, it's going to get the negative sign of negative 3x of 3x minus 4x less than what? This side we are remaining with a negative 6. We are remaining with negative 6. So we have 3x minus 4x. What do we get?
Yeah, x.
We get x. Thanks for that contribution. Who else can try? 3x minus 4x.
Negative x.
Yes, Shigun.
Negative.
Negative x.
Get negative x. Less than or equal to what? To 6. To negative 6. Remember, we need a positive x, not a what? Not a negative x. So what we do, we divide by this negative, divide by negative 1. Remove what? That negative. This one becomes positive. You're going to remain with x. This is, again, there is a multiplication principle here. I think you're going to just cover it in the next slide. That multiplication principle says that whenever I divide, this is multiplication and division principle. Whenever you divide with a negative or multiply with a negative, the sign of the inequality what? Changes. It does change. So this one we divided with negative 1. We are going to cover that principle in the next slide. Not in the next lesson, I'm meaning this lesson, but the next slide. So when divided with a negative, this sign is going to change. To what? To greater than or equal. By changing, we have these signs: less than, greater than. Less than or equal, then greater than or equal. So when it is this one, when it is this one, less than or equal, so it changes to its opposite. I don't change it to this. Just change it to this one. If it is less than or equal, we change it to greater than or what? Or equal. So we get negative 6 divided by negative 1, which is what? Which is 6. So the answer is x greater than or equal to 6. Then you graph. Then you graph it. So this is 0. This is 1, 2, 3, 4, 5, 6. This is 6 here. Then this arrow shows that these numbers, they go up to infinity. They go up to infinity. So this is negative 1, and negative 2. So we are saying x is greater than. So remember, it is greater than or equal. So it is what? forward. So it goes in that what? That direction. So that is the subtraction. That is the subtraction reaction. So I'm requesting that Lisa take you in the next slide. That is when we have the multiplication principle and the division what? And the division principle. Unless when you have a question, but that is the subtraction principle and the addition principle. Yeah. Teacher Lisa, are you there?
Yeah, I'm there. Can you hear me?
Yes, wanted to remove this stop sharing. I don't know whether I have this right.
Yeah, I have them.
Okay. Tekashi, you are raising up your hand.
Is he still raising up the hand? Oh,
No.
boy. Okay. Thank you so much, Teacher Arthur.
You're welcome.
I don't know whether you're going to remain in the background there because now I'm sharing the screen. I'm unable to see.
I may not be able to be there.
I can see Teacher Henry in the background there. Maybe you can take over.
Okay.
All right. Thank you so much once again. I'm going to take you through the multiplication principle and like Teacher Asa has been elaborating on the addition and multiplication and subtraction principles. This is also what we call the multiplication principle. And we are going to consider two numbers. We are going to consider real numbers. Yes.
I'm not seeing the work.
Is anyone seeing this screen? Do we have any person seeing this screen?
Yes, we can see the screen.
Yes, we can see.
The multiplication principle is the one on. I don't know why this one cannot see the screen. So here we are going to consider two numbers. For example, if we have two numbers, like maybe you have 2x, and they are telling us that this is less than or equal to or equal to 5. So the multiplication principle that we are talking about is that when you have this inequality, if you have this inequality, 2x multiplied by 2x less than or equal to 5, and you're multiplying it by any value. Let's say you're multiplying it by 3. It means you're also going to multiply this by 3. This is the multiplication principle that we are talking about. Now, when it comes to multiplying, when you multiply a constant that is a real number, you realize this inequality is going to remain the same because you can mean to say divide by 3, and this inequality, like we have already done, this 3 can cancel out, this 3 can cancel out, and you realize you're going to remain with the same 2x is less or equal to 5. So when we are multiplying inequalities with the same constant, this symbol is going to remain unchanged. It will not change. So that is what we are talking about here. For example, if we have A is less than B, this is going to be the same as A multiplied by C, this C, take note of that C. That C is the one that we are talking about as the constant. This C here. Yes, that C is the one we are multiplying through this inequality, this one here. So they are trying to mean that this inequality is the same as this one. It does not change because you are multiplying this constant on both sides. And that is what we call the multiplication principle. Secondly, if we have A is greater than B, this is the same as, I'm going to clean this. This is going to be, if A is greater than B, this is going to be the same as A. If you multiply it through by C again, it's going to remain the same. And that is the multiplication principle that we are talking about. So this is another blade for any real numbers, A and B. Any negative number C, this is what will happen. For any real numbers, I don't see this. This was a repetition. This was a repetition. I'm going to proceed. What was so important here is this multiplication principle. When we are multiplying through by a constant, the symbol does not change. Hope we are up to that step. If there is any question, you put it up before we proceed. If there is any question. That is for when the value is positive. And when it is negative, for example, we have A is less than B. And we are multiplying it by a negative constant. This time round, this at first it was a positive C. So we want to multiply it by a negative C. So we are going to multiply it by a constant that is negative. And this is going to be, maybe I'm going to multiply it by a negative constant. If we sorry, I wanted to use C. If we multiply it with the negative C, we also multiply this with a negative C. This value is going to change its sign, and we, if we multiply, this is, no, I'm not, this is almost the same. I'm not going to take you through this. It's almost explaining the same principle up here. I'm going to proceed to the next slide. Provided you have any constant and you're multiplying it with any value on both sides, the sign does not change. I'm going to take you to the next screen. And there is a note here. Can I get one person to read through this note? Or is that not bullet number 1?
When you multiply or divide by a positive number on both sides of equivalent, the direction of the inverted constant stays the same.
I beg your pardon. I didn't hear the last one. The network is breaking. But she's trying to tell us that when we multiply or divide by a positive number on both sides of the inequality, the direction of the inequality symbol remains the same. That is one. The second one is here. Someone should read for us the second one. This is like a summary. I'm not seeing the hands up. Make sure you put up the hand before you read something. Yes, I can see the hands up. This is so Tracy. Tracy, you can proceed.
When we multiply or divide by a negative number on both sides of the inequality, the direction of the inequality symbol is reversed.
Thank you. Thank you. She's saying that when we multiply or divide when we multiply or divide by a negative number on both sides of the inequality, the direction of the inequality symbol is reversed. Now, this is what teacher Arthur was trying to talk about in the previous example. Can anyone maybe try to explain this more? Do we have anyone who has understood this last one? Because now this is where we can concentrate. For inequalities, if you don't understand this, for inequalities, if you don't understand this bullet, then you fail to and this. Can I see some hand up if you have understood that statement? Yes, Arnold?
It's like when you're subtracting, the symbol remains the same. The symbol can't remain the same because the symbols are not like they are not this. They can't be changed. They remain like.
I've not got that very well, but you're trying to talk about something. Thank you so much. Arnold, any other person who can elaborate more about this? We need to concentrate so much here because without that, it is going to be very hard for you to understand. Is there any hand? Henry? Henry, are you there? Teacher Henry? He has dropped off.
Yes, Mr. Masar, I'm there, but there's no
Yes.
hand up. Okay, there's now Mrs. Arnold.
Yes, Arnold, can you proceed?
Like when you're subtracting when you are subtracting the equalities, both sides, the number is reversed because they can't be like that of multiplying and dividing.
You're not very clear. We're talking about multiplication. You're talking of addition, but thank you. Let's pick some other hand, Henry, if it's there. Let me see.
Muted. Can we have Muchunguzi? Muchunguzi, please go ahead.
When you're dividing by a negative on both sides, the inequality symbol is reversed.
Well, thank you so much. I'm going to make a demonstration here. Like Teacher Arthur was trying to show us that it was it -3? Who remembers that? You put up the hand, was -3 is less or equal to 6 if you have something like this. Now, this is where we miss it from. If you're dealing with inequalities and you don't understand this step, you're finished. How do you get the value of x in this statement? If you can only understand how to get the value of x in this statement, then you would have summarized the whole inequality. Now, for example, this equation here, I'm going to request you to put in the chat what will be the value of x. I'm not going to solve it here. If this is a, I want to read the values in the chat. And if maybe we have the second question is -2 x. I'm going to use k here. Let me hope you're trying out. You're trying out the first. I want to read the values in the chat. If you can only understand this principle, the one I'm staying on, if we have 2k is greater than 10. The first answer, I want it to be for x. I want you to give me the value of x. Then part B, I want you to give me the value of k. This is where inequalities lie. You don't understand that step, you cannot tell us anything in inequalities. So I'm going to wait for your answers in the chat. I'm waiting for part A. Is there any answer, Henry?
Not yet.
Okay.
There's one from Chigundu.
Chigundu.
X
Chigundu is telling us
greater
that
or equal.
for part A. For part A, Chigundu is saying
X is greater or equal to. That X is greater or equal to -2.
X is greater or equal to -2.
-2.
Any other person? Any other person? I can see people are putting up the hand. Do they want to supplement?
It is negative. Okay, there's one from Tracy.
Tracy saying?
Tracy says X is less than -2.
Less than -2.
Yes.
Yes, Tracy. Tracy, thank you. If there is any person, do you have any other person? Let's keep trying out. Let's keep trying out. If you don't understand this second bullet here, you're going to miss
There
out.
is,
You're going to miss out.
Yes, Masala.
Yes, sir.
There is also Candy, who says I have
X.
got. Who says I've got the same? Now I'm wondering the same as which one, because there are two
Let him
people up there.
unmute. Let him unmute and say something.
Candy, Candy, please. Candy, please take to the floor.
Okay, Candy is not there. We are going to proceed. Now here for part A, we have.
There is one other one.
Yes, yes.
Okay, Candy answers that the same as Tracy's, which is X less than -2.
Oh, so we have two people here.
Then there's Haven, who is
Haven.
saying K is less than -5.
K.
Then Ruth.
K is less than
-5.
Yes, yes.
Then Ruth is saying greater or equal to -2. X is greater or equal to -2.
Yes, thank you so much, Ruth. Now we are going to try to solve it here. We are not going to wait for everyone, but keep your answers coming in the chat. So what happens for this inequality here is that we divide it through X is less or equal to 6. So what we do, we divide it through by -3. I'm going to divide through by -3 because I want to make X the subject. So I'm going to divide it through by -3. And this is where this point comes in. When we multiply or divide a negative number on both sides. Now this is a negative number. We are multiplying it on both. We are dividing it on both sides. It's what this point means. And what happens? Someone should tell us what happens when we divide. What happens to the sign?
The sign changes.
Correct. That is who? The sign has to change. Thank you so much. So what happens here? We are going to get this 3 dividing through by 3, and we are going to have X remaining here, and we shall have this -3 dividing through by this to give us 2. So our answer now becomes, for those who are tried, because the space is reducing here, I'm going to write a small one. Our answer becomes X. You see now this sign is supposed to change because we are dividing through by a negative on both sides. So this sign changes and it becomes -2. So on this presentation, we have 2 different answers, and this is very correct. This was from who? Benjamin. And this was, I don't recall the person. And this person here has tried so much, and these are two people. That is where we miss it from. If you're there, make sure you desist from doing this. Whenever you divide through or you multiply through by a negative value, the sign has to change. Its direction. So the sign has to change its direction. Make sure you have that at heart always. Don't forget that. I'm going to move to example 3 here. And the question is there. Can I receive those answers? Can I receive those answers? Let's try it out. Put the answer in the chat.
So we are not seeing it clearly.
Is anyone seeing it clearly?
It's in small, very small.
Okay. The question is, make sure you have where to write and put it down. The question is 4x is less than 28. The question is solve 4x is less than 28 and then graph it. Graph it. So as I wait for the answers, I'm going to draw my number line here. I know you can get that answer. I know you can get that answer. So I'm going to start by drawing the number line as I wait for your answers. Teacher Henry, when you see any answer in the chat, let me know.
Mr. Masaba?
Yes, sir.
There are some answers now.
Yes, X.
From Muchunguzi, K is greater than 7. From Haven, Muchunguzi has K greater than 7. From Haven, X greater than 7. Ruthie, Misiriza, Chigundu, Patricia, Akelo Grace, Joanna, X is less than 7. All those ones.
X is less than 7.
7.
Thank you so
Candy,
much.
Candy also gives X less than 7.
All right, all right. So thank you so much, Henry, for that. I need to make a clarification here. Well, I'm also trying it out here. I can't believe the answers have already come when I have not got the solution. So we needed to try it out together. We have K. This K was from who? I think this K was a mistake. It's supposed to be X, but we're not going to consider that so much. But at least we have 2 people having the same answer, then more than 2 people having the same answer. Which one? That one gives us an idea that we are all trying to conceptualize the concept. So what we need here is, we need 4x less than 28. That is all we need. So we need to make X the subject. So what do we do when we want to make the X the subject? Someone should tell us what we do.
We divide.
By what?
By 4.
Correct. We divide through by 4. Well, someone should get ready to tell us, is this 4 a positive or a negative?
Yeah, it's a positive.
Correct.
Positive.
And when we are dividing, correct. Thank you. When we are dividing through by a negative, when we are dividing through by a positive, do we change the sign?
No.
No, correct. So when we are dividing through here by a negative, we are going to get this X, this 4 dividing by 4 to give us 1, 1 here, making X the subject. And because it is a positive, we are not going to change the sign. And our answer would be what? 7. So x has to be less than 7, and we are going to have this group of people passing, and this is going to be wrong. This one, first of all, you need to, if these are marks, you go below, because you know you already have this mistake, then plus a wrong answer. I really don't know. So this is also wrong, but thank you so much for trying. And next time, ensure that you copy the correct thing. If it is K, you put K. If it's X, you put X. Is there anything from the chat, Teacher Henry? So our number line is going to be here. I'm going to represent this one.
What we have, Mr. Masawa?
2.
We have another.
Don't mind so much about those 2, 3. Yes.
Mr. Masawa.
Yes, sir.
We have another X less than 7. There are only X less than 7, X less than 7.
Oh, that is correct. X less than 7 was the correct answer. I've already told them that. So we are going to graph this value. We are going to put it in a number line. So what is going to happen is we are going to look at that and we put, so we are going to look for the values of X that are greater than 7. So those values include what? Someone should tell us those values that are less than 7. They include as someone prepares to tell us. This was in the first example. Was the first lesson that we looked at. So you draw an open circle there because of this sign. So it means 7 is not going to be part. And we tell the examiner that the values of X that are less than 7 include 6, 5, and so on, something like that. And that was what in this solution here. So I'm going to clean off this board. And maybe for those who are putting it down, the first step is you rewrite the question. And the second step is you divide through by the constant, which is a positive. And the answer becomes X is less than 7. So you don't change the sign because it is a positive value. Example number 4. Get ready to give me these answers. Example number 4 is very good. I've already seen it from this side. That is the question. We have negative 2y is less than 18. I'm waiting to see those answers. Negative 2y is less than 18. Who gets it right, first of all? I want to see the first value of y. In the chat, Henry, is there anything?
We have y less than negative 8, less than negative 9. Yes. We have y greater than negative 9.
Who are those people? I need to know their name.
Tracy says y less than negative 9.
Tracy.
Chigundu says y greater than negative 9. Candy, y greater than negative 9. Tekashi, greater than negative 9. Ruthie, greater than negative 9. Joanna, greater than negative 9. Aven, Muchunguzi, Patricia, Mercy, Acho, greater than negative 9.
So we have 2 answers. Y is less than 9 and y is greater than 9. Let's see who gets it right. The first step is you rewrite what the question has given you. Then the second step is you divide it through. And for those who are keen, are we dividing through by a positive number or a negative number? Is there anyone who has seen that?
Yes, it's a negative number.
Correct, it's a negative number. And what does our second rule say when we are dividing through by a negative number?
The symbol changes.
Correct, and our answer becomes y is greater than negative 9. So what happens here is this group of people, I don't know who are you and how many are you. all who are having this, you need to check your working very well such that you understand that second. And many people were writing that, and that is very correct. Thank you so much. Tracy, I heard of Benjamin, I heard of who else who was putting that. I didn't hear the names well. Thank you so much. That is very correct for those who put y is greater than 9. Any question around here? Because now, if you don't understand this principle, don't come to any class of inequalities. You will suffer a lot. I need to know, Teacher Henry, who gave me this y is less than 9? I need to know this person and see if we are moving together.
Who gave the greater?
No, the less.
It is Tracy. Tracy gave less.
Tracy is saying y is, Tracy was saying y is less than 9. Now, Tracy, this is what we're talking about.
Also,
when we are dividing through by a negative constant. Okay. So is there Tracy? Is Tracy still there such that you maybe tell us where could be the problem? Tracy, are you there?
There is also a fire Ruth.
Yes. Yes, Ruth. Is anyone there to defend why is less than 9? Maybe we can take that as the correct answer. Yes, Tracy and the group there who maybe dropped. I can't hear from them. So make sure you avoid that. Every time you're dividing through by a negative, your sign must change. We are going to, yes, let's get someone to read for us this. Let's get someone to read through this, because this is a very important conclusion in inequalities. You don't understand this. Let's get someone to read this. Are you there? Yes, Chigundu, can you go ahead?
Remember to reverse the inequality symbol when multiplying or dividing on both sides by a negative number.
Yes, this is the conclusion that we must learn today. If you have a book, can you have this put down? I'm talking to senior 3s. Don't think you're in senior 2 anymore. You don't have this in your mind, just know you're going to suffer with inequalities. If you have where to write, can you put it down? The likes of Tracy, I heard of Foyo Ruth, and you have this, you don't have this, inequalities will not be your friends. And in most examinations, they try you around that area. So make sure if the examiner brings that trick, you're dividing through by a negative constant, you respond correctly and you don't get it wrong. So with that, we are going to go to an example, another example 5, and there you go, it is there, example 5. And this one, I'm going to try it myself. So here, what you do, like I told you, rewrite the equation like that. And this is 6 minus 5x is greater than 7. So what you do, you take the 6, the other side, when it crosses this other greater than symbol, this one you treat it as a negative, you treat it as an equal sign, it will become a negative. So 7 minus 6, what will be the answer there? 7 minus 6. Is someone following?
1.
Correct. We get 1. So we are going to have negative 5x greater than 1. Now here what we're going to do, we're going to divide through by a negative 5. Did you see a negative 5? And when you see a negative 5, it means what happens to the symbol? We're going to divide through by a negative 5. What is going to happen to the symbol?
The symbol is going to change.
It is going to change to what?
To a negative.
To a negative, the symbol.
To a positive.
Less than.
We only have 2 symbols, greater than or less than. So the symbol will change to what?
Positive.
Positive. To less than. Correct. Thank you. So we divide through by a negative value, and our symbol will have to reverse this other side, and our value becomes x is less than minus 1 over 5. Example number 6. There is that one. Now I'm going to wait for your answers because now we need board mass around here. Are you able to see that question?
Yes, sir.
Yes. Let's try it out. And these examples, you write them down because we have that Padlet where you're supposed to put these answers. So for those who are writing it down, after this class, you take photos and upload them in a Padlet, but you write on them that these are examples. If maybe we put it here. So let someone give me that answer. We are getting late. I'm not going to take a lot of time. You don't give me the answer early. I do it myself here because of time. Is anyone having the answer? Yes, I'm waiting for your answers. For the don't want to delay on this. Yes, I can see Arnold is already giving us that X. Arnold already has it that X. Let's keep those answers coming in. Arnold in the chat, I can see he has X is greater than 1.5. Someone should confirm for us that answer. Any other person to confirm this number, this answer? $1.5. Any other person with the answer, or else we proceed? Can I hear from someone? Are you still trying out? If you're trying out, can you unmute and say something so that I give you some time?
Yes, Masara.
Yes.
There is one who has given x less than Tekashi. Tekashi has given x less than 1 over 6.
Less than 1 over 6.
1 over 6.
Yes. Yes, thank you. We now have 2 answers. Is there anyone trying out? Say that we wait for you, or else we do it. All right, I don't think someone is trying it out. All right, we're going to try it out. Yes, I can see answers are coming in the chat. Heaven has x is greater than 6.3. And not yet there. I can see
Chigundu has
Benjamin is giving me x is less than. Yes, Chigundu. Let me write it here. Maybe we can bet on Chigundu. Chigundu has
-1. I think it is -1 and 5 over 6.
5 over 6. Any other answer?
Ruth Astrid, it is x less than 4 and 3 over 4 whole number 3 over 8.
3 over 8. Yes.
Muchunguzi has x less than -21 over 8. I hope it is not 2 whole numbers 1 over 8. It could be 2 whole numbers 1 over 8, but the way they are writing, I don't know. Then Jessica, Vanessa, Muchunguzi.
Yes, Muchunguzi, should you tell us, is it 2 whole number or it is 21?
-21 over 8.
Okay.
Okay.
You were saying, Mr. Henry, you were saying the next one is who?
Is Jessica Vanessa with x greater than 2.625.
2.625
to 5.
To 5.
Then Laura.
Yes.
Laura has -2 whole numbers 5 over 8.
Negative
2 whole numbers 5 over 8. 2 whole numbers 5 over 8.
5 over 8. All right, I'm going to stop there because of time, but keep the answers coming in the chat. So what
that is where they are stopping for now.
Okay, so what we are going to do is we are going to open this bracket. We are opening that bracket together. It's going to be 3x minus 6 minus 1 is less than 2 minus 5 minus 5x. What is going to be the next value here? Minus 5x. Someone is there?
Minus 30.
Minus 30 or plus?
Minus 30.
Minus 30, correct. So when you open that bracket, it becomes like this. Is there any person with a problem around this step here? Because this is the most dangerous step.
No, sir.
All right. If there is no question there, so I'm going to clean out. I'm going to clean out this. And I'm going to show you the solution. So what happens here is you open that bracket, and when you open the bracket, that is what will be there. I didn't know that I'd written there. So when you open the bracket, it will be this. Minus 30 is the one that I was talking about. So let's see the next step. You rearrange. This 5 comes here. And this is going to the other side. And our B, 3m minus 23, minus 30, it becomes minus 28. The next step is you collect the like terms. 5 comes here, 7 goes the other side. And we have x, 8x is going to be less than 20, negative 21. So we are going to divide there. We are going to divide through by 8. And when you divide through by 8, our answer becomes x is less than 21 over 8. And when you put 21 over 8 in the calculator, it becomes negative 2.625. So we have several correct answers on this on this chart here for those who brought. So this value becomes correct. Who was that? Who gave us that value? I don't recall that person. Was that who? If you give us x is less than negative 21 over 8, that is very correct. And when you put in the calculator, this one also becomes correct. And when you put that one also becomes correct. It becomes 2 whole number. Let me confirm that. This is wrong. This is wrong, unfortunately. This is wrong. This is wrong. The correct improper fraction, the correct mixed fraction is supposed to be x is less than minus 2 whole number 1 over 8, something like that. Let me see. Let me confirm here. 21 divide by 8. Let me confirm. All right, it is 5 over 8, sorry. It is 5 over 8. This is 5. Let me clean this. This is 5 over 8. So the person who gave me this answer was almost correct, but because of that 6. Did you write 6? The person who gave me this, maybe it's me who wrote it wrongly. Did you write 6 or 8? This value. Make sure you check your working. You wrote 8.
Yes.
In the chat. Did you check in the chat?
Yes.
All right. Maybe me, I picked 6 and we shall have that. So this becomes the correct answer. This becomes also the correct answer. And this one is also the correct answer. So we are going to proceed. We're going to proceed. I have an exercise after this, and we're going to put that exercise in the Padlet. But there is this example number 7. And this one is going to involve the LCM. It's going to involve the LCM because we are getting data. I'm not going to spend a lot of time on it. I'm not going to give you a lot of time to try it out. But the biggest point to note there, if you're given something that has the LCM, that has denominators, you look for the LCM. And when you look at these values, 3, 6, and 2, what is the LCM?
6.
Correct. The LCM is going to be 6. And that statement is talking about what you have just said. The number 6 is the lowest common multiple. So it's going to be this one that we are going to multiply through. And when you multiply through by that, this is what will happen. we are going to multiply through by 6 everywhere because it's the LCM.
Yes.
Are we there?
Yeah.
I'm moving very fast because of time. So when you multiply through by 6, this is what happens. This 3 will cancel out with this 6. All right, let me see. The LCM here. When you get this very well, you realize this 3 will cancel out with the 6 to give you 2, and this you're seeing here. And this 6 will cancel out with the 6 to give you 1. You're going to try this and see how it is beautiful. And this 6 will also cancel with this to give you 7. And this will be 6 multiplied by 2 to give you 10. I'm not going to take a lot of time. Takashi, unmute your microphone. I'm getting a lot of feedback. Takashi, thank you. When you multiply through by the LCM, that is what you're going to see. And now when you reach here, it becomes the ordinary inequality. And we are going to take the negative, we correct the like terms here. So we take the -1 this other side and the 12 this other side, and this is what will happen. So let me get from you 7 minus -12x is what? 7x minus -12. Someone should confirm that answer.
-5.
7 minus 12. The answer is -5x. 5x. Correct. So we have -5x is going to be greater than 8. Are we going to divide through by a positive or a negative constant? I can't hear. Someone should tell me. -5, correct. So what will happen to the sign? Will it change or remain? Yes, the sign is going to change, and we shall have our x less than -8. Something like that. Is there any question here? Because that is the last slide. I know it has been, I've moved very fast because of time, but the whole concept is getting the LCM up there. So I challenge you to try to put this down, get the LCM and follow, and make sure your answer is -8 out of 5. Is there any question there before I give you the exercise?
No.
All right. There is the exercise. We are going to do this exercise, and we are going to post it in the Padlet. This exercise is very sweet. When you see part A, part B, up to part D, I think D is repeated, and that is supposed to be part. Which part is that? That last one? A, B, C, D. It's supposed to be what?
E.
Correct. That part is supposed to be E. So we have part A up to part E. You're going to do this work and post it in the Padlet. Some people have not yet known how to use this Padlet. The Padlet, the link that we give you, let me share with you this link. You're supposed to post it in the hand-in Padlet, not anywhere. So I'm going to copy this link and put for you in the chat here. Have you seen that link?
Yes, teacher.
Yeah, that is the link for the Padlet. So when you click on this link, you're going to go to the home page of the link of the Padlet. Don't post anywhere the work. I'm going to try to. Did you copy the exercise? And I'm going to share the exercise in the chat here. Let me put the exercise in the chat such that even if I remove the screen, you can go back and correct the exercise. Let me put it in the chat. This one.
Mr. Masar.
Yes, sir.
It's 4 p.m.
Oh, I was sharing that exercise in the link. Are you able to see that exercise in the link?
Yes.
You're going to do that exercise and post the work in the Padlet. I'm going to stop sharing the screen from here. And the teacher Arthur, you're back? I saw teacher Arthur.
He's around, he's available.
Yes, thank you. All right, I want you to do that work and put it in the Padlet. We are going to stop here for now, and we're going to request someone to give us a closing prayer. Clever?
Heavenly Father, we thank you for this day. We thank you who has led us through these lessons. And Father, as we are going to depart, we call upon your Holy Spirit, come and guide us for whatever we have learned, so that it can be kept in our mind. Bless our teachers and bless everyone who has attended the lesson. And to those who have not attended, you bless them so that they can attend the next day. In Jesus' name we have prayed and believed. Amen.
So much for that prayer, and thank you so much for coming. Have a good evening.
Good to see you too. I'm taking you a post because I'm moving to a mathematics room. Yes. No, I'll be staying on, but I want you to have the posting rights. Yeah, it's for you, to Deborah. Whom should I make host? Okay. Oh, okay.